So I try to kind of like what you're doing with your newsletter, to customers. I try to bring some clarity through visualizing and mapping these concepts to their problem sets. One thing every customer wants to do is the models are great, but I want to make sure that it is accurate with the task that I'm trying to achieve.
Welcome to Humans of AI, where we tell the real stories of those who are building an AI or are making use of it in their daily lives. Today's guest is Govind Kamtamneni, a member of Microsoft's Azure Global Black Belt team, helping to drive clarity on the capabilities of Microsoft's Copilot and cloud-native stack. He is deeply passionate about the transformative potential of technologies that are at the frontier and is focused on fostering the wider adoption of AI for intelligent apps. If you want to catch the latest episodes, make sure to subscribe. And check out my free AI newsletter, Chaos Theory. And find me on social at Alex Chowmander. Now, without further ado, here's my talk with Govind.
Hello, everybody. I'm here joined with Govind, my friends and colleagues here at Microsoft, working a lot on AI, trying to empower and bring this new technology to several enterprise customers. Govind can definitely do a much better job introducing himself, so I'll pass it off to him. Govind, who are you? What's your origin story? And yeah, go ahead.
Cool. Hey, Alex. Thanks for the opportunity. It's always great talking with you and in a podcast setting. So hello, everyone. My name is Govind. My last name is a little challenging. It's Kamtamneni. It's 4 syllables. I'll talk about my professional career and where I started. It started in 2006 at IBM, where I initially was a software engineer, focused on a bunch of traditional sort of what you might think a software engineering job entails. And that product was FileNet when I worked on it, which now morphed into the Watson data platform. And after 4 years, it was quite impactful and rewarding. But I wanted to kind of see where it's being applied. So I joined IBM's software group, Expert Labs, to help customers kind of diffuse some of these capabilities and build like sort of information systems. Initially, it was line of business apps, and then end user apps, applications, and sort of modernizing into cloud. So I did that for a decade. I worked on some. A lot of these projects kind of start from the user needs and then go all the way to production. So some of the names are like Hertz or Delta, like end user, consumer facing applications and stacks. So I kind of built that. So that's again super rewarding, where you get to see what it is. And between that time period, I kind of majored in computer science, did a master's, and then between that, I also got an MBA from the University of Chicago, sponsored by IBM. So super thankful to them for that. And the reason I did that is because I really like how, technical capabilities are great, but then when sort of capital is allocated to diffuse them and solve the real need, seeing that and being part of that is super valuable as well. So I wanted to kind of understand the mental models of like basic, how is capital efficiently allocated, so all that piece, that kind of merging technology with the business domain. So I really enjoyed learning those topics and applying them. And then I've been dabbling in so the poster behind me is the standard model of particle physics. So I've been sort of deeply passionate about the sort of mysteries of that poster. It's insane that like humans, by through the language of nature, mathematics, we're able to codify the fabric of reality, if you will, in an equation form. Yet it is not complete. There are a lot of gaps there. With there's gravity is unexplained. The intersection of quantum physics and classical physics is not incomplete. So there's things that we don't know yet, but there's a lot that we do know and that we do apply through engineering and solve problems. So that part, and then I read books like David Deutsch and all these books that kind of highlight that the limiting factor is really intelligence. It is the fact that maybe our evolution programmed us, to only perceive the world in 3 dimensions. We work with models that are like, many thousands and, millions of dimensions, right? So there's something there that maybe is limiting, but with intelligence, which the definition there, the definition that I subscribe to is the one by Santa Fe Institute. I really like that one, which is, it's just the reduction of uncertainty. So if we look at it in those lens, there are things about the universe that I think like, or about why we exist. Like, why are the lights on? Why are we talking? Like, what is consciousness? These unanswered questions. Hopefully, we can understand. So that's why I've been deeply fascinated with that topic and been paying attention. I did Coursera courses and Udacity and kind of self-taught some of the machine learning primitives. And then 2017, 2018, like all the buzz around, especially like especially when OpenAI was releasing some of the stuff in DeepMind. Like I've been following what they're doing. It's clear we're on some exponential here, and to see that kind of diffuse so quickly with ChatGPT, it's insane. So I've been so anyway, so at IBM it was rewarding, and then I switched over to Volkswagen, Audi, Porsche. They were building a self-driving car, so I thought I could apply and learn some of these deep neural nets and how they're actually used to solve real world problem, and they are doing a good job, but I think they'll say it themselves, like Tesla is like a decade ahead, and definitely the players at the frontier are like Tesla, Waymo. So it was good, but then I wanted something maybe maybe go back to what I was doing, helping customers. So this Microsoft job, I work as a global black belt here, working with your team, semantic kernel team, which has been super rewarding to see that being adapted by enterprises and how they're solving problems.
When Govind says he's a global black belt, it really is literally a black belt because he's coming in like saving the day. Maybe black ops is a better term, but no, I think he works on the thorniest, like most difficult problems that enterprise face. Uh, Customers ranging the whole spectrum, and especially in this current AI moment where everyone's so fascinated, as you said, with ChatGPT, with the capabilities of large language models. A lot of enterprises are just trying to figure out what to do with it. Could you maybe talk very high level? Obviously, you can't don't name names or share anything you don't that we can't talk publicly. But at a high level, what is it that you're probably most currently working on?
Sure. Um, so before I do that, I just want to say about my team. So you're right. It is. We try to be at the frontier of technology. Try to incubate new tech to our customers. And in my team, everyone sort of narrowly focuses on one area, and they go super deep. So everyone's like specialized. And the cool thing is, I have full autonomy to do whatever I want to do, but I am accountable to be impactful. So that allows us to kind of follow our passion really and just go deep. And so what I've been mainly focused on is our Copilot stack. I think that's a good sort of catalytic framework that was announced at Build by Kevin Scott. And at the center of it is the orchestration layer, which your team semantic kernel does a good job at fulfilling. So to answer your question, what I do is try to drive clarity to customers that have these technical, there's a lot of uncertainty right now. There's a lot of, orchestrators. There's a lot. Our stack, Azure itself, has so many services. There's so many shiny Lego blocks, but customers care about like how to compose them and build the objects that they care about. So I try to drive clarity, in that using, some samples and frameworks and tools, and try to first understand their problem really and understand what the end user need that they're trying to serve, and then kind of work backwards and then try to see which Azure service or open source, whatever kind of fits and solves the problem. The other one is unblock them, when they're blocked. So it's really two things, drive clarity, especially with our incubations, and then to unblock in their technical journey.
Yeah, you mentioned incubations. One of the things that I've seen you do and create is this project called Miyagi. Do you want to maybe give the listeners a
Sure.
rundown or at least an overview of what that is?
Sure. Yeah, absolutely. So again, another sort of context. So before Miyagi, I was working on another sample called Red Dog, both of which you can find under Azure or Azure Samples. And the reason this is something that I've done it before at IBM, and I see my team at Global Black Belts also do is we go and we talk to customers and we kind of look at their use cases that they're trying to solve or want to solve, and usually there's an overlap with the type of use cases that customers are trying to solve. And so one thing is, how do you sort of create that repeatable pattern for customers to inspire from, to look at it as a blog post or through code, how can you like essentially get them started on their use case. For personally, like I need a canvas to kind of go deep and learn these things. If I'm just talking to customers all day, I'm not really applying things. I'm not really coding and getting to the nuts and bolts and or bits and bytes of things. So I need like a sort of surface area to do that. So like we create these samples. So last year it was Red Dog, which is a retail store, and before any sort of orchestrators existed, I just showcased how you can bolt on AI with just OpenAI to do like generative product description for personalized medicine. Or in diffusion model space, I have a personalized. Let's say you want to do pill creation. I can show the demo of that, but basically it just uses the diffusion model to create medical images. Or so this year, with the orchestrators, everything changed, right? So we wanted to kind of go back to the drawing board and see how else we can capture all the use cases that we're seeing in a story, because we humans, we talk in stories. So we came up with this story of like a Robin Hood or like a financial advisor. And then my colleague David Barkle, he kind of was watching Karate Kid with his son. So he suggested, so my original name was Copilot or Private Copilot, which was honestly boring. So he suggested, hey, you looked at this character that teaches karate concepts through wax on, wax off type of thing. And I was like, all right. So that name sounded really cool. So we came with Miyagi, and all it is a collection of use cases that showcase through code and how to use semantic kernel. For example, the retrieval augmented generation pattern, or essentially to synthesize information. And then the other one is you guys have this Copilot chat sample, which is really awesome. But customers, I'm hearing this a lot, is they want to take that Copilot chat and adapt it to their own front ends. It could be a mobile app, it could be whatever, right? So in this case, the Miyagi front end, which is a different front end, uses your Copilot chat web API as the back end. So it's showcasing customers, hey, this is how you can take Copilot chat and use it for your use case. So just things like that.
Very cool. Very cool. If you have it on hand, do you
Yeah.
have maybe some sort of like mind map or something to walk us through the
Yep.
the mind of Govind and how he approaches problems, how he solves things, or even just what you've already solved so far?
So I like that you talked about like a mind map or a mental model, and that's how I like to think about things. So this is a slide deck that I've been trying to kind of pitch customers a lot, just kind of showcasing, how can you infuse AI and develop these intelligent apps with semantic kernel, Copilot stack, etc. Just kind of set the stage. I like to think in terms of like how we are going to approach this, sort of like the mental models of things, if you will. People are going to baby step their way to embed intelligence. I think like it's going to be a phased approach, if you will. And I think the first phase is always like, okay, at the end of the day, it's just an API call. I can just go spin up a model and they'll have an API. It's a REST call. I'll just go ahead and play that. And I think we do a good job with the OpenAI playground. You kind of start here. And I think anyone who starts with the OpenAI models have kind of done this. You play with the temperature or whatever, and then just do some chat stuff, or chat GPT. That's the way it works. And then the other one is yeah, you start to kind of learn concepts about in context learning capability that they have and prompt engineering. And then I think the next phase is to start, augmenting your own sort of authoritative data sets to make the model's output more relevant for your needs. And that's where I think, orchestrators like semantic kernel can play a easy role to be able to do augmentation and achieve domain specificity. There's obviously like plugins now with the whole OpenAI function extensions. This is where you might get exposed to vector stores, and then you'll, kind of understand that the models are representing information in a certain way in these high dimensional vectors. And there's actually a lot of value in taking your information, sort of vectorizing, getting those embeddings, and there are these purpose-built databases or database extensions that allow you to store and retrieve. So there's all these concepts that you get exposed to, and then you get exposed to these new design patterns like the RAG pattern to ground the model's output. And then there's the new way is to kind of give agency, right, to build these agents. And I think Semantic Kernel's Planner, which is evolving fast, does a really good job at allowing you to do that. There's a lot of closed loop ones as well. So I like to think in these mental models. The other mental model that I have, I'm still working on this diagram, but basically how to achieve sort of domain specificity or improve task accuracy.
If we could go back one
Sure.
slide and double click on
Yep.
specifically the agents
Yeah.
piece.
Sure.
Do you want to maybe give your high level thoughts on just what do you think about agents overall? At least today, they are the buzzword of the day
Yep.
in the AI field. Everyone's trying to build an agent or trying to explore the limits of what agents can do. Do you view it as a like groundbreaking new thing? Is it more hype than reality? Where do you fall on this?
I've never seen this amount of change and adoption as I think we're all going through right now. And I think there are multiple areas of exponentials here, right? So number one, it's the model architecture itself is evolving fast. Just before this call, I was reading about this LogNet thing that Microsoft just came out with. And by the way, Alex, I have to give you prop. You do a great job with your newsletter, the Chowdowns, where you distill and synthesize all this information, and it's really cool. I try to follow that. There's state-space models, so there's a lot of model architecture that is sort of evolving from this sort of decoder-only, self-attention transformer, right, that we're used to with ChatGPT. So that's going to continue to like get better and better, and they really are like this. Their job really is to predict the next token for now, and there's no like, I mean, which it does a great job at because it really the sort of what is it chinchilla optimal scaling law, if you will, that it was trained on, allows it to have these emergent capabilities where it can reason, etc. But it cannot plan, right? It cannot like we have system one, system two thinking, and maybe it lacks that system two thinking. And we don't know. We don't know like the power, like its ability to predict the next token. Um, maybe is maybe it's not fully understand, or maybe it's not fully grasped as to how crazy it is that it is able to represent and understand things. So what I'm saying is it cannot really plan as well. So in order to do that, we're augmenting the model or really wrapping it and giving agency to the orchestrators. So I think there's actual like companies out there like Replica, Character AI, um, a few others, and they, in fact, some of the Microsoft Copilots kind of do this too. I don't know if you played with Perplexity AI. They introduced this Copilot that kind of does this crazy planning. It asks you questions. It's reasoning. It's that whole reason and action type of thing. Um, so the orchestrator is the one that seems to have that agency. And in fact, I don't know if you've been following what Jan LeCun is going out there and doing. He's basically saying that there's going to be these world models, and like there's going to be a reward model that is going to augment the large language model. And anyway, there's all these architectures that are emerging, and I think agents are the way we are primarily going to interact with these models. And there's just going to be many agents. In fact, I'm pretty sure Facebook is about to release like a ton of them between WhatsApp and all the product experiences that they have. So that I think for sure, like even though when you get started, you're not going to like make your orchestrator kind of agentic, I think that's where it's just going to evolve. And as consumers, we're just going to kind of experience through these agents that have intelligence.
What would you say is the main blocker or hindrance or thing that's not there right now, preventing more people, more companies, more enterprises to adopting agents today?
Yeah, so it's really gets into really sort of creepy territories. I mean, we work with a lot of industries or companies that are in regulated industries. I mean, forget about agents, even just the model, a stateless model, running inference on it is problematic because data sets are extremely sensitive and there's all kinds of, compliance and laws and regulations that they care about. So giving a freewheeling agent to just do whatever, with your data set, and I mean, think about what it can do, right? It can like semantic kernels planner, if we take that, it breaks down a task and just round trips with the large language model. And you can also give it connectors and data sets. I mean, they can be prone to like prompt injection attacks. I mean, all kinds of security loopholes can be exploited here. So I think companies, that are especially not in like a competitive sort of marketplace are more, prone to like regulation. They're more careful. So I doubt they're going to adopt anytime soon. Like maybe not this year. I think maybe in some niche cases, but consumer apps are going to for sure. Like I don't know if you played with Replica or Character AI. Like that's basically what's going on behind the scenes. Like in Replica, it even alerts you like to proactively take care of you kind of or your mental health. So I think they're going to explode. I think the most important thing, I'm part of this project called the Gato project. I don't know if you heard about that one. So so I think one of the most important concerns here is the reward model or like the objective function that it is trying to optimize for or maximize. That is the how the reward model is encoded in the agent. So, we all know with social media, like it's basically the algorithm is to maximize attention. So, we all know the problems about it. We're not going to get into it. But that's because the reward model is about are you going to click the ad or not? Like that's how, they make money. So, if we go down this path and if we start coding reward models to sort of maximize the short-term profitability of a company, I think it could be problematic because these things can exploit our sort of reward system that we have as Homo sapiens, if you will, with like a dopamine induced. Like, I mean, TikTok is a classic example. It's like doom scrolling all day, right? People are, I mean, at the end of the day, nobody actually feels good about it, but we're kind of addicted. It's like it's messing up with their sort of, addiction circuitry, if you will. So I think it's important to align that reward model to maximize sort of that overall human well-being. And this Gato project, if you will, they're doing a good job. They kind of codified some ways to kind of, some axioms that they think will help humans, like, reducing suffering or all kinds of things. Anyway, we're going off topic, but but this is that's why, like, when we get into agent territory, I think that's where regulation is going to come into play big time. So, but it's happening fast.
For sure, for sure. Yeah, I mean, to me, it seems like the one of the main challenges and the broader, maybe philosophical challenges, like where do you put the control of these technologies, right? In the past, right, when we would effectively say like, okay, if I'm going to run a program, it just runs deterministically, inputs and outputs, and control the flow of that. But with these agents, right, with AI effectively being able to come up or make its own decisions and even make use of tools or functions or capabilities, plugins that are either explicitly like given as how like the semantic kernel does it, or maybe it can build its own tooling, or write its own code bases. Maybe I think that it just starts to get a little nerve wracking to imagine like, oh yeah, the control is starting to go away from the programmer or
Yeah.
the user, and now
Yeah.
into this AI.
And to your point, I'm especially scared with these closed loop ones. Like I'm sure Auto GPT and Baby AGI, you've probably heard about it, I'm sure. And actually Microsoft has something called Jarvis. Like, that stuff is where, human is kind of taken out of the loop and it's maximizing whatever, reward model, like whatever objective function was encoded. And who knows what that is, right? So, but yeah, so far I think hardware is a limiting factor, so it can only go so far. And also the fact that it's not really connected to like an actuator in the real world. Like that intersection of bits and atoms are they're getting there, but they're not there yet. Like it's not going to actually, like, I'm sure you're following the media. It's like Terminator style, like kill us. Like I don't think that's going to happen yet, but I think, like, for example, what Elon is about to ship, I forget what it's called, Artemis, yeah, Prime, something like that. Yeah, the robot, it's going to be in
Mm-hmm.
your home that will help you with your chores, which is great. But I think if he doesn't open source the reward model that it is trying to maximize, it's going to be a little bit problematic because it's really a kind of closed loop agent with, access to sensors and actuators. Like, I mean, I don't know what it can do with his hands. I mean, they can be dangerous. So anyway, yeah.
Yeah. I mean, both of us have spent some time in the self-driving car industry, and we've seen, the attempts to try to marry the real world and the digital world, and it's not always pretty. It doesn't always work, and can actually cause some real fatal impact. So
I'm curious, where did you work at before?
I was at Uber. Uber's
Oh, okay,
advanced technologies group.
nice.
Yeah, working. Spent some time in Pittsburgh, Pennsylvania, and then came to the Bay Area. But all throughout that time was mostly focusing on computer vision, sensor fusion type problems, as well as actually just like how do we combine all the data that Uber has collected over time, right, with their knowledge about where business actually happens, where people want to go, right? And how do we join that with the self-driving capabilities? Because at the time, it's like, oh, self-driving cars have a hard time doing unprotected left turns, right? Or
Hmm. Yeah.
uh, especially in Pittsburgh, where there's a lot of hills, right? The cars, based off their sensor array, can only see so far, especially if you're climbing up an incline. So anyway, so all these like sort of problems where, yeah, there's like literally, it's not this to say that the technology isn't there. It's just more you're dealing with the real world and the unpredictability and variability of it.
Yeah, and the consequences are huge. I was listening to, Dara's interview, and he was saying how I know that project you're working on got kind of spinned off or something like that, divested. But he was saying how, like, imagine if even if there's one fatality, a year or a month or whatever, right? There's likely going to be more. Imagine if you're a company and you're having to kind of go defending that, in society, like, oh, only 2 people died this year, like something like, even though it might not be their fault, it's still the long tail of possibilities are endless. So it's a hard problem.
For sure. For sure. Is there any more that you wanted to show
Yeah.
off with
Um.
your mind
I,
map?
yeah, I think we kind of started with that mental model. So this is another one that I tried to kind of create. So I think we're all visual learners. There's a lot of concepts and text. So I try to kind of like what you're doing with your newsletter, to customers. I try to bring some clarity through visualizing and mapping these concepts to their problem sets. One thing every customer wants to do is the models are great, but I want to make sure that it is accurate with the task that I'm trying to achieve. So one thing I kind of laid out is, look, it's a trade-off, with how you do that, like everything in life. So you can, and basically, what I'm trying to do with this one is mapping the main ways that we can achieve sort of domain specificity with these models. And I think most of the time, we're going to just be doing prompt engineering, right? Exploiting that in context learning capabilities that these models have, where there's sort of zero shot prompt. Oops, there's all these concepts, right? Like zero shot prompting, or all these knobs and configurations that we can adjust to get the model to be more accurate. And then there are all these prompt engineering topics as well, like few shot prompts or role prompt and chain of thought, tree of thought, and all these patterns, right? We can have a whole hour on these topics. And then I think orchestrators like semantic kernel is how you can sort of infuse AI and do prompt engineering in a sort of scalable fashion, if you will, with your product experiences. So I think that's where it's very important. And most of the time, like for most folks, if you have models that are like 4K, which is about 5 pages, or 8K. So one thing for the audience that might not know, these models have limitations on how much context it can hold, depending on the model. I think the max that we have with GPT-4 is 32K for now, and that's basically roughly 40 pages of text. And if you have about like 100,000 tokens, if you will, or type of domain knowledge that you want the model to follow, I think prompt engineering you can achieve. You can chunk that stuff and then do, like retrieval augmented generation pattern and things like that, and try to get more accurate responses by just doing prompt engineering. So this is what I tell customers, like, hey, you don't need to, like, there's a lot of talk about fine tuning and stuff. And yeah, there is maybe some value there, but most of the time just stick to prompt engineering. And I think if you want the model to like focus on a few areas in its response or output in a certain style, like you're maybe a customer, um, a call center copilot or something, and you don't want the model to like pontificate on some random topics. You want it to, let's say, stay focused on call center topics. You can like fine tune it. It's not going to learn new knowledge per se, but at least it will, try to um, be a better version, for your task, if you will. And this is the whole RLHF stuff and all that. And basically, Microsoft, we have, Azure ML Foundation Model Hub or Catalog, where you can fine tune models, these open source models. And then you can also like leverage our optimization stack or our parameter efficient fine tuning methods that Microsoft Research can open source. And it's pretty much the industry norm to use these two type of things. And then the other one is really like what Bloomberg did, with Bloomberg GPT. Kind of, if you want that differentiated, you know, capability in a model, then you really can do like a data mix and pre-train your own. Maybe this is where in 3 years everyone will be, or a lot of people will be. But for now, it's super expensive. You require a ton of data. Like we're talking billion plus tokens and a lot more actually. And then it's super expensive. And honestly, there's not enough GPUs to do this stuff. So just trying to visually map for customers, again, to drive clarity. Yeah, this is just another mental model that I try to employ.
Yeah, this is really good. Really, if you're a hobbyist, like ML person, or just trying to tinker with stuff, to if you're like a very advanced enterprise. Interestingly enough, it's not the case that, oh yeah, advanced enterprise, just go for the pre-training approach. If anything, I think because there's this capacity constraint problem right now, and will likely be for the foreseeable future. Yeah, as you said, retraining or training these models from scratch, even if you did have all the data, which is already a hurdle in and of itself. Yeah, it's a very expensive endeavor, and it may not always be better than just regular or more effective prompt engineering. So,
Yep.
I do like this breakdown a lot. Very helpful mental model.
Cool. Yeah, and then I have a few others. This is just talking about how GitHub does. I found this cool blog post where, again, I like visuals that explain, sort of first principles. When we use GitHub Copilot, yeah, it's great, but I really want to understand. And there was this really nice blog post on GitHub Copilot X, I think something. Like it really talks about how they do it, and it's pretty much what people are doing with semantic kernel with the RAG pattern, right? They have a vector database that's local, but it's the same idea. They have a prompt library, they, augment and then send that to the model. And then, yeah, it's doing the same thing. And then show that ghost text, and then you hit tab, and then it completes. But of course, it's, more efficient, I'm sure, with how they do it. So this is really how customers are kind of trying to adopt the Copilot stack. So in order to do that, again, I have this sort of sample and this workshop that kind of tries to surface up these concepts through use cases, because I think like we humans, we care about like stories and how it solves our problem. So while there's a lot of stuff there, I think if we just break it down, like if we were to distill a lot of these things into like the sort of first principles of it, they really are solving. For example, the main thing is synthesis, like the whole world of like I do a keyword based lookup, I get a bunch of blue links, I go click on them, and in my head I try to synthesize, is gone. I think it's just like I have a question, I have an answer, you do all the orchestration, whatever, and then just answer in natural language. I think that is going to be the way most companies are going to adopt. So I have an example with semantic kernel, like how you know that pattern can be achieved using like a vector database and using connectors and plugins. But through like an actual use case, I try to surface up, okay, now this is how you do that. This is how you initialize the kernel. This is like how you have your prompt template, or in the skills, how do you tweak the configurations? and then I need to complete that. But basically, these are native connectors. How can you, just the whole thing, through code and through a story, I try to convey. And I have other use cases as well that I'm kind of documenting, like how, like the whole traditional sort of, there's a generative AI and then there's discriminative AI, right? Like how do you, like a traditional narrow ML model can now be rethought. Maybe you don't need like this, one model that was trained on labeled data sets to, I'm sure you've seen like Jin Yang from Silicon Valley,
Hmm.
right? Hot dog, not hot dog, right? Like
Hmm. Hmm.
I think that is changing too. Like, okay, you have one size fits all, general purpose model. Let's apply it to do classification or traditional machine learning tasks like named entity recognition or obviously summarization. There's just so many. Like it's crazy how much we can do. So that's kind of the approach I'm taking with this. And yeah, the sample that you mentioned with that is Miyagi, which, by the way, thank you for also kind of talking about it. And I try to catch or keep up with how much you guys are doing. It's kind of hard, but it's trying to highlight like all the semantic kernel capabilities through those use cases and also others as well that I'm seeing from customers and within the sort of thing about the Copilot stack. So like within our Copilot stack, we have like a bunch of things there. Like how can we, use that to build these new front ends? Like a plugin on ChatGPT, and how do you make use of new concepts like vector databases and all that stuff within like by using like traditional sort of Azure primitives. So there's a lot of like APIM, basically like a gateway plus the model pattern that we're seeing a lot from customers. So we're trying to highlight that here. And how do you host a ChatGPT plugin securely behind like Azure in like an enterprise grade setting? Yeah, just things like that.
Yeah, and it's fully open source, right? People
Yeah,
can
yeah, yeah. Yeah.
go and
Anybody can
look at
go
it.
in and yeah,
They
absolutely.
can run their own workshop probably
So
if they
that
wanted to.
is the idea. Some things you can't. So for example, I have two modules, the architecture design session and the discovery session, where actually I have a sort of link to John Maeder's design thinking as well here. But essentially, I have like a Figma template that customers can kind of fork, and then they can start like it can be like an active session where we can pick whichever mental model that they're familiar with, either jobs to be done or whatever, and then this way, as they go through the workshop, it'll be more relevant for their use cases. And the last section is like an architecture design session that is also one-on-one with the customer. But other than that, the other use cases, yeah, I'm hoping to kind of document here and kind of do it on your own type of thing.
Very cool. Very cool. All right. Well, that's a very thorough, compelling walkthrough. I think it's amazing to see the inside the mind of Govind. So thank you for walking us through that. I have some more questions. So from your like survey or like working with all these customers, and even just playing around with a lot of these things yourself, what would you say is something that people are not paying enough attention to in AI?
Yeah, so I think it goes back to the world that you and I came kind of came here from at the intersection of atoms and bits. There's a lot going on where the general nature of that reduction of uncertainty, that synthetic intelligence, if you will, is getting diffused. So if you think about like what DeepMind is doing with AlphaFold 2 in the protein sort of what is it, protein folding problem, where it really changed like the field of chemistry or biology, like or yeah, what Microsoft research is doing in the field of medicine, and even DeepMind, you know, I think that's going to change like big time. Like the amount of like technology is a great has been a great deflationary force, but so far in the world of like bits, I think it's about to go into like atoms, and we see that with this being applied in the basic sciences, of course, but also in sort of robotics. Waymo, you were in San Francisco, right?
I was just yep.
I heard that you guys are seeing like a self-driving car all over the place now, like whether it's Waymo or all these other companies.
Yeah, oh, yeah, yeah. It's all over. Cruise, Waymo,
Cruise,
and
yeah.
a bunch of other ones.
So I think that's just going to go into every city. Like it's, I mean, yeah, it'll just be a norm. Like you will get a car with no driver, and it'll just feel like whatever. It's mobility. We're going from place A to place B. Um, and also food delivery. It's gonna, it will be a deflationary force. Like the whole, yes, it will take away some jobs, but whatever it's trying to solve, it's just gonna be cheap. Like energy is another one. I'm reading about nuclear fusion, like that is going to kind of drive energy down to zero almost. So energy is one of the, well, right now the major sort of bottleneck is really the substrate that these intelligent things run on, which is GPUs and also the memory and the network, all that thing. So I think that will catch up to demand. But as we're seeing with our customers in Azure, there's capacity constraints because of that. And I think that's a limiting factor to applying these technology into the world of sort of atoms. But it's going to happen. Like robotics is huge. Whether even like what Tesla is doing and what others are doing with, you know, uh, I don't know if you have a Roomba or something, that does, but it'll do more than a vacuum. Like it's getting weird. And then what Covariant is doing with like these robots in um, like yeah pickers and all these things too. Like so. I think that's a space where I think there's capital being kind of flowing in that space, but not a general attention. But because of how connected we all are, I think it'll diffuse super fast.
Yeah. Yeah. I think technology in its history, right, has seen these really disruptive moments for sure. That, yes, has resulted in job loss, but certainly a lot of job creation. New industries have formed, and yeah, it's incredible that we might be in one of those moments right now, and just seeing all this change happen, and even having a part of like seeing that through, right, and participating in that. So I think that's been super exciting. What would you say, Govind, then is something that you personally are excited about for the future?
So for me, it always goes back to that poster, like the deep mysteries of physics. I mean, hopefully, if we can make progress in that direction of like just understanding, like abundance is great. Like I think the universe is abundant with natural resources and energy. But what is scarce is really like, human attention and human consciousness. So like if we kind of, allow like just research folks to use, these, I mean, I think someone did a survey or something. I know it's going to be controversial to say it, but it's kind of true. Generally, like a human population, higher IQ folks are in like these, theoretical physics or like the deep basic science research or applied math. If they can leverage these models, imagine like getting their IQ or having them be 20% efficient or something. I just feel like we're gonna make some major breakthroughs in I don't know what happened before Big Bang or something like that, right? Uh, like I think that will just I don't know, be satisfying for curious folks. Like this has been a journey. Like humanity has been on a journey to know why we exist. Like maybe we'll finally know, or maybe I don't know what the answer is. 42 or just being on the journey. Yeah, we'll see. So that part is
Yeah.
exciting. Yeah.
Since you mentioned the reference, I guess, are there any sort of favorite books or movies that you would personally recommend? I don't know if Hitchhiker's Guide to the Galaxy is at the top of that, but
Yeah, it is.
uh,
Yeah, that one's definitely good. The other one, I actually have my books here. The other one that I'm kind of rereading is this one, The Beginning of Infinity by David Deutsch. This is a really good book. Yeah, I think this is one of those, deep books. It's written by yeah, he is the father of quantum computation. He's a professor of physics at Oxford, so he's really a deep thinker. And then the other one that I'm kind of rereading, actually, I read the first edition, and now I'm kind of going through the third edition because it's important to kind of stay plugged into the first principles. I'm sure you've seen this book, this one, right? That's on
mhm,
machine learning.
mhm.
Yeah. So third edition just came out, and it's really good because it, you know, is updated to have like variational autoencoders like the diffusion models or yeah, transformers. I think was not even mentioned in the first edition, but now it is, and kind of goes into the depths of it. So I think that book is really cool. In terms of movies, this one show that I just finished watching, Silo on Apple TV. That one's really good. It's a little bit dystopian, but I'm not gonna give away anything. But basically, it is based on a book series. So it's in a popular book series. So it's really good. Yeah, that one was good. And also, I don't know if you saw this one, Severance. Did you watch that one?
I have not yet
Oh,
watched
okay.
it.
That one's good too. Yep.
I've seen at least the trailer, and it seemed pretty interesting.
Yep.
So cool. Well, as we wrap up, one actually final question from my side is to the listeners. Govind, what would you give as your advice to people who are looking to break into either the field of AI or even just people who are just trying to make sense of everything that they're seeing on the headlines? It could be maybe very jarring or unsettling for some. I guess what general advice would you give?
Yeah, I think just like I mean, I hate this follow the passion advice, but it's really like focus on what user need that you're currently trying to solve, or a problem that you think society has or you have that you want to solve, and work backwards from that and see how these AI capabilities that are emerging can solve. That way, like whatever you learn is just going to be more relevant and you can apply it instantly. And there's so many ways to get started, like, whether it's Coursera. I mean, I personally started with Andrew Ng's, course, as most people did in this space. I didn't go to like, a university or anything. And there's also a ton of YouTube content, I'm sure, but always like keep your eyes on the problem that you're trying to solve, or like whatever you're passionate about, because that's just the only way things can be relevant. And because some of the, like, especially when you go more deep, you're going to see that it's all just a bunch of calculus. It's all a bunch of math equations, and in order to keep that interesting, it's important to kind of um, you know steer it towards what you're trying to solve.
As much as follow the passion is very cliched advice, I think the passion at least gives you that motivation to be like, okay, I'm going to go through this next Coursera course. I'm going to open up that textbook that I have on the shelf.
Yep.
And yeah, I mean, it's a driving force for sure, and we all need to cultivate it in our unique way.
Yeah,
So
absolutely.
Govind, thank you so much for the time. Thank you for an awesome discussion, a great one. And yeah, I mean, if people want to follow you or catch up with you in some ways, how can people find you?
Yeah, so I'm on Twitter, T2 Govind. I don't know if I'm going to move to Threads from Facebook soon, but we'll see. So that's one way. You can also hit me up on LinkedIn. But one more plug for your newsletter. Please subscribe to Chowdowns. It's really cool. Like I'm, paying attention to it, and I don't know how you can do that. Like every day, you're synthesizing so much information, but it's for a reader, it's really useful. So yeah, that's a good one.
Well, thank you for the shout out. Yeah, Chowdowns is my daily portion of the broader chaos theory newsletter. It's all play on my last name. So
Oh, chaos theory. Yeah, now I see it.
yeah. But anyway, awesome. Well,
Awesome.
thank you again, Govind, and yeah, have a great rest of the week.
Thank you, Alex. You too.
Hey, thanks for listening to Humans of AI. If you're building something with AI or have perspectives you want to share, drop me a note at alex@humansofai.xyz. And be sure to subscribe to my newsletter, Chaos Theory. Until next time, this is Alex, Resident Chaos Coordinator.